Now if you try to calculate the arithmetic mean from the each and every set of data, we are able to get 47. If you are seeing this graph, you are able to identify there, you are able to identify kids, male, female, elder, older, everybody we are able to identify. Range also classified two category, which is coming under absolute, one more is relative. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. So we are in the Unit 2, Session 1, third semester BCom, measures of variance and skewness. So in this chapter, today my agenda. So about the measures of variations, or you can say the measures of dispersion, both are same. The meaning you will get to know, okay? And the absolute and relative measures of variance. Okay, one by one, moving forward, you will get more idea, more clarity about what is the meaning of measure of variance or measure of dispersion. So the measure of dispersion or measure of variance, both are same. See, when you are seeing this image, you are able to identify there is a senior most female, small kids. Okay, now you have to find out. The measure of dispersion is nothing but the value or data is spread. Okay, so the group of analytic tool that describe the spread or variability of the data set. In the previously we studied the concept like measures of central tendency. With the help of measure of central tendency, we are able to identify one single value. But here the data, each and every set of data, how it is spread, what is the difference, the range you have to find out. The variations part, okay, which is related to the variability. Okay, now in this image you are able to identify there are different people we are identifying, even the small kids, male, female, elder, older. Okay, everybody is there. Now each and every one you it is the data set will be spread. Okay, moving forward. So here there are 5 set of data is given here. Let us 5 set of observation. See, each and every set we are able to identify first, second set, third set, fourth set, fifth set. 5 number of data observation is given, 5 numbers is given. Now how many set is given? Here 4 set is given. Okay, now if you try to take the total, okay, when you are trying to do for the measure of dispersion, even the standard deviation and arithmetic mean, which is very similar, the value is similar. Now if you try to calculate the arithmetic mean from the each and every set of data, we are able to get 47. Okay, now we are not able to identify the difference. So for that reason only we are trying to do for the measure of dispersion. Each and every set of data, what is the variations, difference we are finding, okay, the range you are finding, okay, the difference. So each and every set of data, the total you are getting 235. So first set also you are getting 235, second set also you are getting 235. Now if you take first numbers 45 from the first set, second number, second set 45, third set 44. Okay, now the each and everything, the variations when you are finding. Okay, for example, from the X series, if the value after calculating arithmetic mean, for example here x bar is already calculated in this problem. So 47, arithmetic mean is 47. Now for example here the X series also given 47. There is no variations, right? So X 47 minus 47, the variations will be 0. Again the 47 minus 47, the variations will be 0. So in this case we don't have any difference. So but other case when we are trying to calculate when the different set of data, of course we are taking a criteria for X bar here. The question remain unanswered even after getting the mean. Now here in this case 5 set of data, the mean is always common, 47 we are getting. So how will vary the data set? Now we need to get an idea or get an clarity about each set of data, what is the variations we are able to identify. We need to identify how do the value in each data set differ from each other, but we are not able to identify because the mean is getting 47. Okay, now for that reason only the measure of dispersion, there are 2 types. One is absolute and relative measure of dispersion. Okay, So how are the value in each data set clustered or dispersed from each other? For example, 45, 45, 47, 48. Now the difference, what variations we are finding, we are not able to find out the variation. For that reason, we are trying to do for the under measure of dispersion. Okay, measure of dispersion, absolute or relative. We will get more clarity when you are doing a problem. Moving forward, the importance of the measure of dispersion. The first one, the supplement and average or measure of central tendency. The central tendency, I think you get a more clarity. The central tendency, the mean, media, mode, what we are doing. So in that we are able to identify only one center value. But here the difference of each set of the numbers, how many numbers are given, we are not able to get. So that's what we are trying to do for the measure of dispersion. The first one, the complete supplementary average and measure of central value, and compare one group of data with another, because in the last slides you got and there are 5 set of data is given. Now we are comparing, but after calculating, take this in sigma x, the total value you are getting 235 divided by number of items. Okay, say the 235, each set of data we are getting 235 divided by numbers. How many numbers here we can observe? 5 numbers are given, so divided by 9. Now equally x bar is getting 47, and indicate how representative in the average. Now if you are seeing this graph, you are able to identify there, you are able to identify kids, male, female, elder, holder, everybody we are able to identify. So that's what, which is a representative data. Now each and every one we are going to separate. Now under measure of central tendency, very important concept, the absolute and relative of measure of variance or measure of dispersion. There are two types, one is absolute and relative. So we will get one idea about the absolute means what, and relative measure of central tendency, what the difference. The measure of variance may be either absolute or relative. So the measure of absolute variations are expressed in terms of original data, because the last chapters, first section, you can get an idea about original data, whatever it is given in the question. So same thing, original data basis only we are able to calculate on absolute variation. Okay. So in case two set of data are expressed in the different unit of measurement, then the absolute measure of variations not comparable, because the two set of data is given. In the previous slide you got, and there are 5 set of data is given. So when there is a comparisons, we are not able to apply in this absolute variation. So that's what we are trying to go for, the relative measures. Okay. So in such case, measure of relative variation should be used. The variations we are trying to go for, always we are considering coefficient is always coming under the relative measure of variations. The other type of the comparison for which measure of relative variations are used involved to comparisons between two set of data. If one set of data is given, no problem, we are trying to depend on the absolute. If the two or more set of data is given, of course we are trying to go on the relative variation, because we are using coefficient concept here to find out the variations level. So having this same unit measurement but with different means. So in the last 4 set, whatever it is given, we are getting mean is 47, 47, 47. Each and every set we are getting same 47, the mean value. We shall now considering in turn each of the 4 measure of variance. Okay, so the each and everything when we are getting, after calculating arithmetic mean, if a different arithmetic mean value are getting, so in that case we are trying to identify. So the data around the central value or mean, in the central tendency, we are able to find out only one single value, like mean value, median value, mode value. The measure of dispersion is divided into two parts. One is absolute measure of dispersion and relative measure of dispersion. What is exactly absolute measures of dispersion? Absolute measures of dispersion is used to compare two different set of data if they are in the same unit. Now if you take the total, you are getting 235, 235, 235. Every set of data you are getting same total. Okay. So moving forward. So here the absolute and relative measures of variation, the measure of dispersions can be expressed in the several way. So here we have a different types of using a measure of dispersion. We are classified into majorly absolute and relative. So again further we are identify which is related to the absolute, which is related to relative measure of dispersion. So here see the range when you are trying to calculate under based on the position of an observation in the distribution, the data set whatever they are giving, the data set either they can give for vertical or horizontal. So we need to observe the data whatever it is given. So each and every distribution we going to observe very carefully. So when the based on the position of average, we are trying to calculate an average, okay, and quartile deviations which is related, and even the mean absolute deviation. Okay, all are range also we can find out the absolute measure of dispersion. Even the quartile deviations also we are able to, here quartile deviation means Q1 and Q3 we are finding. The formula I will explain in the next slide. And the mean absolute deviation using a arithmetic mean or x bar or median or mode, we are trying to calculate the mean absolute deviation. Of course here there is a limited drawbacks. So for that reason only we are trying to go for the mean absolute deviation here. So the mean absolute deviation and variance or standard deviation. So whatever it is there are four types we are able to identify. One is range, quartile deviation, mean absolute deviation or mean deviation you can say, or variance or standard deviation. Variance which is directly going for the coefficient variance. The measures of the dispersion around an average basis when we are trying to study. So of course the standard deviation when you are calculating, we are using a mean as a average or mean or average. We are taking a weightage. Okay. So even the mean deviations also when we are calculating, we are taking a average only. Okay. Even the standard deviation when we are calculating, we are taking the mean is an weightage. So when we are trying to calculate coefficient is nothing but your relative measures of dispersion. Whatever we have discussed here, range, quartile deviation, mean deviation and standard deviation, which is coming under the absolute. For each and every absolute, when we are trying to go for the coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation, we won't say, but instead of coefficient of variance we can say only for the variance. For the symbolically you will get in more clarity in the next slide. So under absolute and relative measure of variance, so the first one what you have seen in this diagram, the first one is range. Again range also classified two category, which is coming under absolute, one more is relative. So here the range is the simplest measure of dispersion. The range is the simplest measure of dispersion. The formula is very simple. The data set whatever it is given, for example data set is given 50, 40, 30, okay, and 20. Now from this data set we are choosing lowest is a L, okay, L is equal to 20. Now highest is a 50, H is equal to 50. So the range formula very simple. Range formula is the maximum value from the data set is 50 and the minimum value from the data set is 20. The simple formula to calculate. The range is easy calculate. Of course there is too many drawbacks. We are not able to exactly focus. So and it is easy to understand. Range will not give the correct picture. Okay, so about your data, and it is easily affected if your data set has a outlier, because each and every data, if the data difference what we are getting, we are not able to exactly focus here. So the range is defined as a difference between the highest or numerically large. Okay, in this data set, highest is 50, meaning lowest is a 20 value. The lowest is a numerically smallest value in the data set. In symbolically, when we are representing R is equal to range, H is equal to highest value, and L minus sign, and lowest value from the lowest set of the data, lowest. R range, H is the highest value, L stand for lowest value. When you are trying to solve the problem based on the discrete data group or ungrouped data or continuous data, then you are getting a more clarity. Okay, moving forward. Then of course, what you have studied in the last slide, which is related to absolute, when we are talking related to the relative measure of the variance, which is nothing but in the free, we are just writing the coefficient of range. Okay, so now coefficient of range is related to the relative measure of variance. So the coefficient of range is a ratio. Now when we are taking for the numerator and denominator, so of course, which is giving a correct ratio, the portions are dividing. Okay, so the difference of highest and lowest value in the frequency, what the data set is given. Now from the data set we need to identify. Again, when you are seeing the data, you need to identify properly either a discrete ungrouped data or discrete group data or continuous data. Of course, as a statistician, as a statistical student, you have to observe very carefully. The coefficient of range formula is simple. In the previous slide, you can get an idea. The formula is R is equal to H minus L. So whatever it is there in the range, which is the numerator also, same thing. But in the denominator, instead of writing minus n, we are just going for writing one more time, but sign is changed. Okay, the relative measure of corresponding to the range called coefficient of range. Whatever the range formula is there, with the help of formula, denominator, numerator, we are trying to numerator the same as it is in the range, whatever the formula is there, same thing. The only denominator we are writing, but sign also we are changing. It obtained by applying the following formula. This formula we are able to. So what they are asking in the question. So according to the question, we need to carefully we want to read and observe the data, which is discrete or group data or ungrouped data or continuous data. We need to carefully observe. Moving forward. Now, the second type of even the absolute and relative, when they are asking, when they are not written like a coefficient, which is coming under the absolute. So, the quartile deviation, quartile means what? 4. Okay. So, how the quartile 1, okay, and quartile 2 is nothing but your median. Okay, even the quartile 3 is quartile 3. Each and every Q1, Q2, Q3, but according to quartile deviation, whatever we don't want Q2. Okay, just for your understanding, Q2 is nothing but your median. But according to formula, whatever it is there, we need to calculate. Okay, so the quartile deviation, also known as semi-interquartile range, it is computed by taking an average of the difference between average means yes, the quartile 3 minus quartile 1 when we are writing. So of course we are finding the difference. The third quartile and the first quartile. In this symbolically this can be written as QD stand for quartile deviation. Quartile means what? How we are getting. I am writing, see how we are writing, getting the Q1 value. So Q1 value is equal to Q1 is 1 into, okay, in case of discrete data, ungrouped data means n plus 1 we are writing, divided by 4. Okay, so in case of discrete data, group data or continuous data, both are. So Q1 is equal to, instead of writing a small letter n, we are writing capital letter N divided by 4. Why we are taking 4? Because quartile is always dividing 4 part, right? That's what. So in the same thing, how we are getting Q3? Instead of writing 1, I am writing Q3 place. So 1 place I just want to replace 3. So in case of discrete ungrouped data, small letter n divided by 4. Okay. So if you are taking for group data, 3 into n by 4. Getting? Okay. So in absolute, now you got an clarity, but relative measures means we are just adding for coefficient. Clear? So the corresponding to quartile deviation is called for coefficient of quartile deviation is calculated as given below. So whatever the original absolute formula is there, Q3 minus Q1, the numerator we are writing as it is, but denominator instead of writing 2, I am writing Q3 minus sign plus, I am just writing plus. The same thing, only the sign is changed. But here we are dividing only 2. But here we are dividing Q3 minus Q1 divided by Q3 plus Q1. Okay, moving forward. So under absolute and relative measures of variance, now we are in the third deviation, so which is called average or mean deviation. So in the last two deviations, we are getting a limited abstracts. Okay, there is too many in the last the two methods what we are range and quartile deviation, there is something drawback. So for that reason, to overcome that drawbacks, we are in the we are trying to go for average or mean deviation. So the average, the name only suggesting when we are trying to calculate based on the average, like x bar or mean or median. So the measure of average or mean or deviation is improvement over the previous two measures. Which one? Measure range as well as quartile deviation. So in that, considering all the observation in the given set of data, so in the previous two quartile deviation and range, when we are trying to calculate, the set of data will not give you exact the deviation. But here when we are trying to calculate an average deviation, we are able to focus, we are able to overcome that problem what we are facing in the pre-methods. This measure is computed as a mean deviation because we are taking average like a mean or median mode. So mean deviation from the mean or median or mode. All the deviations are treated as a positive regardless of sign. Positive means if you are calculating, if you subtract, if you are getting minus sign, we are not bothering about the sign. We are just ignoring the sign here. So in symbolically, this can be represented by, so arithmetic mean deviation or mean deviation of x bar. With the help of x bar, we are calculating. The formula is, when in this case of ungrouped data, discrete data, ungrouped data is given, the formula is very simple. From the x series, for example, the x data, the data set will be given 40, 50, 40, 30, 25. Okay, so like this, from this x series we are trying to calculate an x bar. You know the formula is x bar is equal to sigma x divided by small letter n. So take the total, you are getting sigma x. Now if you try to simplify, now according to this formula, we are trying to calculate a mean deviation of x using x bar, sigma x minus x bar. Now according to that formula, whatever it is there, we are trying to construct one more table. So that is nothing but x minus x bar, because with the help of x we are calculated x bar. Now this formula in the numerator, it is having a sigma x minus x bar. That's what we are constructing one more table, x minus. Now if you try to take the total, which is nothing but your x minus x bar. Now according to the formula, we are trying to construct a table. Okay, now in case we are trying to do with the help of median, so the formula same, only x bar we are try to replace on median. Okay, m, or you can calculate a arithmetic mean deviation from the mode. Okay, so the same thing, sigma x minus mode is symbolically representing z divided by small letter n in case of ungrouped data. Moving forward, So in the absolute or relative measures, what we have studied now in the previous slide, we studied only for absolute variation, measure of variance. Now relative measures, how we are calculating, how we are thinking, if there is any coefficient of variance is appearing, no doubt it is related to relative measure of variations. So theoretically speaking, there is an advantage in taking the deviation from the median, because the sum of the absolute deviation, just ignoring sign plus and minus, suppose see I have written like this, my x minus x bar, okay, or in case of a median, x minus median, the median and x bar, how we are calculating, there is certain steps in the last section I have already explained. So the sign after calculating, now for example in this case, when you are try to take your x bar value, you are getting for example 40, you are getting, so 50 minus 40, if you try to do, you are getting plus sign, okay, the plus. Now there is 40, here it is getting, now here see the 10 minus 30 minus 40, if you do, so you are getting minus 10, but in this case the sign is completely ignored, we are not considering for the sign, okay. The symbolically the formula, according to the formula, now here moving into the coefficient here, the theoretically because of sum of absolute sign, ignoring a sign plus or minus sign from the median is minimum. So in actual practice, however, the arithmetic mean is more popularly used for computation of average deviation. So arithmetic mean, so there are three media, with the help of mean we are trying to go for calculating a mean deviation from mean deviation from median, mean deviation of mode. So mean deviation of mean, it is always familiar computation average deviation. So under group data, discrete data, if it is given, so what we need to do, the formula only which is added, sigma, instead of writing a sigma x minus x bar divided by n. So now we are just replacing small letter n place I am writing capital letter N, sigma f into x, because the frequency are given, the number of observations are given. That's why the formula based, the data set whatever they are given, based on the data set only we are trying to decide which formula is suitable. So in this case, the group data is given, sigma mean deviation of x bar is equal to sigma f into x minus x bar divided by capital letter N. In case of median, nothing, the same thing, sigma f into x minus median divided by N. In case of mode, it's given sigma f into x minus z divided by N. So now whatever it is coming, which is related to absolute, okay. So in the coefficient which is related to relative measures of variation, the formula whatever you calculated, the first one absolute, now you are considering for the numerators, what you after calculating this value, you are getting average deviation of x bar, the same thing you are writing in the numerator, denominator you are writing x bar, okay. And even if they're asking to do with the help of median, the same thing, after calculating median, average deviation from the median, so the same thing you are writing after getting specific answer, now you are writing in the numerator as it is divided by m. In the mode case also same thing. Now which is related to the absolute, now related to relative measure of variance, so how you are calculating, nothing, you are just adding for the coefficient of mean deviation, okay, coefficient of mean deviation. The formula very simple, mean deviation about the mean. Now if you are trying to take this mean deviation, what you are calculating, the same thing here, which is an explanation here, okay. So coefficient, when you are calculating, what you are calculated absolute, the same thing you are writing for absolute numerator, and denominator you are writing x bar, because you are using the x bar value. Now if they are asking to calculate coefficient of mean deviation for median, same thing, mean deviation, coefficient of mean deviation, okay, you are writing just median. So the same thing, the median absolute whatever you calculated, numerator you are considering, denominator median. And the same thing you can with the help of mode also you can do, the coefficient of mean average deviation whatever it is given, but we are considering a mode. So the same thing, absolute we are taking numerator, denominator, mode we are considering. Moving forward, next standard deviation. So next absolute measure of variations will be standard deviation. The standard deviation is very popular deviation technique, okay, where the most of the area they are using a standard deviation. Okay, in this standard deviation is the most widely used and important measure of variance. We are considering it's very important variance here. So in computing the average deviation, if you are trying to calculate standard deviation which is completely based on the mean, which is completely based on the average. Okay, average means if you are able to find out x bar. X bar, if you are trying to simplify, sigma x divided by n in case of discrete ungrouped data. In case of discrete group data, sigma fx divided by capital letter N. So now which is completely depending on average related problem. If the formula is having always having a x bar is a mean is having. Okay, so the sign are ignored, the sign are also ignored here. The standard deviation overcome this problem because here the sign is if it is minus sign or plus sign, when it is going for the square root, of course it will be always for the positive sign. Okay, so overcome the square deviation which make them to all positive. If the negative also getting, which is giving positive because having a square root. The standard deviation also known as root mean square deviation, because the formula having a root, right? That's what which a root mean of square deviation is generally denoted by the lowercase Greek letter really called sigma. This symbol is, you can call it as sigma or standard deviation symbol. In symbolically this can be expressed as, in case of again the data, when we are trying to blindly we can't write the simple formula, because based on the data, whatever the data is given, either discrete data group or ungroup and continuous data, of course we need to identify either you are going for the direct method or step deviation method. The formula is little varied. Okay, little changes are there. So of course under ungrouped data, so discrete data, the formula, the standard deviation symbol square root, inside the square root sigma x in x minus x bar. Okay, all to the power of square. Okay, there is one more divided by n. There is one more formula here, say the square root of the standard deviation is called variance. Variance means actually when you are writing only sigma, so that is only for standard deviation. When you are writing like the square, which is nothing but your variance. Okay, so variance, so when you are trying to calculate coefficient of variance, you will get more clarity. So therefore the variance will be symbolically representing sigma square. The standard deviation and variance became a larger as the larger than the centimeter within the data. Okay, become greater. More important, it is readily comparable with the other standard deviation, because when you are comparing standard deviation, the team 1, team 2 or group 1, group A, okay, or one specific players like cricket players, so you are comparing, right? So each and every deviations we are able to identify. That's what it is a popular techniques. And greater than the standard deviation, the greater of variability. If there is a, after calculating a standard deviation, you are getting greater. So that means what? The greater variability you are finding here. So in case of group data, the formula is very simple. The group is always having a frequency. So when it is having a frequency, again one more time I am writing here, the standard deviation symbol. Now it is the standard deviation means you have to remember always there is a square root. So sigma place f into x square. Okay, now the set of data, if it is given the discrete group data, of course there is, you are able to identify the set of x series. Okay, divided by capital letter n. Because why you are writing capital letter n? Because the frequency are given, so you are writing for capital letter n. Okay, and the same thing whatever it is a sigma fx divided by capital letter n all to the power of square. Okay, now the formula is having a almost you are able to identify this is related to mean and this one is also related to mean. Okay, so when we are trying to simplify this formula, or you can take, this is called a direct method we are doing with the help of direct method. Now this is called step deviations method we are doing, or assume meaning formula we are applying. Okay, you know the how you are finding the u value is equal to x minus assume from the x series what you are assuming, that is a. Okay, and the standard deviation, again, when you are trying to apply for step deviation, either you can write for d square or you can write for u dash squares. Okay, when you are comparing, suppose group A you are considering u, group B you can consider for v. Okay, so there are different symbols or different alphabets also we can use here in the formula. So because when you are taking a deviation, of course we need to write a small letter c. Okay, so from the data, when we are trying to solve the problem, you will get more clarity. The formula, how you want to remember, I can tell you the tricks here. Okay, where d, because in the formula having a d, how you are getting d? From the x series, whatever the data set is given, now you are assuming that it is an x. From the x series only we are assuming any one is a assume mean. Okay, that's what we are writing. A is a assume mean. Divided by c is a equal distance. Each and every class having a width means you have to take a equal distance is there means c you have to take. Either you can apply for this formula or you can apply for this formula. So this formula, why you are writing u dash instead of writing u? Because equal, the distance will be, for example, 10, 20, 30, 40, equal distance here. Now it is looking like a discrete. In case of continuous data, for example, 0 to 10 or 10 to 20 or 20 to 30. Okay, so either when you are trying to solve the problem based on the continuous series, now you need to identify which data is related to inclusive or exclusive. Identification is very important here. So in this case, u dash, how you are getting? U dash is equal to nothing. D, instead of writing u d, I am writing u dash. U dash is equal to x minus a divided by c. Okay, moving forward. Next, now what you are studying in the standard deviation, which is coming under the absolute. Okay, when you are trying to study the standard deviation which is related to relative measures of central tendency, of course we need to say it is a coefficient of variance. Symbolically we are writing CV. The CV formula is very simple. Okay, the frequently used relative measure of variance is the coefficient of variance, denoted by CV. CV means coefficient of variance. This measures is simply to ratio, because ratio, how we are getting, if anything is multiplied with the 100, then percentage, which is related to ratio of the standard deviation to the mean expressed in the percentage. So in this formula is very clear here. Coefficient of variance formula, CV is equal to standard deviation divided by x bar into 100. Now according to this formula, whatever it is, you need to calculate standard deviation and x bar, mean value, because the formula having a sigma as well as x bar. So according to this formula, the data set will be almost, you need to calculate each and everything. So whatever it is required. When the coefficient of variance, now this is called decisions making or your comment. Okay, the coefficient of variance is less. When in case of x bar, if it is more means those person are having a better. So you want to decide who is better. So now when you are deciding to who is better, now you are considering for x bar. X bar, after calculating a 2 person who's getting more, they are the better. In case of coefficient, why you are calculating decisions is related, because you need to give a conclusion last or decisions making. So in the coefficient of variance is less after calculating two set of data or two team. So those who are getting very less coefficient of variance, okay, data, it is said to be less variable. You must remember, less variable and more consistent. Okay, after calculating only we are able to get. For example, team A is getting 0.1. Team B is getting 0.5. Okay, who is better? I want to do for the x bar value. Now, who is more consistent means I can say who is getting less. They are the more consistent. Moving forward, keep on watch for next section. Thank you.